do you think of when you think of the desert? Scorching sun, mirages, and lonely cacti, right? But wait, what if I told you that in the hottest place on the planet, you could freeze to death just a few hours after the sun sets? Sounds absurd, doesn't it? Why is that?
This isn't a trick. It's one of nature's most spectacular physics magic shows. Today, we'll uncover the mystery of why the desert, the ruler of daytime heat, transforms into a giant freezer at night.
To understand this story, we first need to reset our definition of a desert. Forget the heat. The key word here isn't hot, but dry. A place is called a desert when its annual rainfall is extremely low, under 250 millimeters. So what does that mean? It means that Antarctica, the coldest place on Earth, is also technically a desert. Strange, isn't it? The Sahara and Antarctica, two extremes of hot and cold, share the same classification. They are like two best friends with opposite personalities, but one thing in common: the air there is bone dry.
And this dryness is the crux of the matter. Imagine our atmosphere as a giant greenhouse roof. In humid places, this roof is full of water vapor. Water vapor acts like an invisible blanket, trapping the sun's warmth.
During the day, the sun shines down. At night, the Earth radiates heat back. But this water vapor blanket traps a large portion of the heat, preventing it from escaping entirely into space. That's why nights in the tropics are still hot and uncomfortable. But what about in the desert? There's no blanket. The desert sky is crystal clear with almost no water vapor. The greenhouse roof here has a giant hole in it. During the day, sunlight is unobstructed, punching straight down to the ground with its full force. The surface temperature can easily exceed 50, even 70 degrees Celsius, hot enough to fry an egg on a rock. But when the sun sets, the magic show begins. Without the water vapor blanket, all the heat the ground has stored up during the day begins to radiate straight out into space at a dizzying speed. This phenomenon is called radiative cooling. It sounds dangerous, but it's really just the Earth breathing out heat.
If the air is the first main character, then sand is the villainous sidekick. Sand is an extremely poor heat retainer. It's like a hot-tempered friend who also cools down quickly. It heats up very fast, but it also cools down in the blink of an eye. Let's do a little thought experiment. With the same amount of sun, a sandy beach will feel much hotter on your feet than a grassy lawn. But as soon as the sun is gone, the sand will cool down much faster. That's exactly what happens in the desert on a massive scale. The combination of two factors, a leaky sky that doesn't hold heat, and a ground surface that readily gives away all its heat, creates a dramatic, break-free temperature drop. Going from 50 degrees Celsius during the day down to 0 degrees or even sub-zero temperatures at night is a common occurrence. So, why can you freeze in the desert? Because the dry air and sand can't hold on to the sun's heat. How do animals survive? By being clever. From building their own luxury bunkers to swimming through sand, nature's survival strategies are a testament to its genius. So, we have the answer to the first part, why it gets cold. But the next question is even more interesting. How can life survive in such a harsh environment that changes as erratically as a moody person? From the slow-moving scorpion to the spiky cactus, all are masters of survival with unbelievable strategies. They don't just survive, they thrive in this combination oven and freezer. What's their secret? If the desert is a survival game, then the animals here are all pro gamers. They have three main strategies. One is to hide, two is to adapt their form, and three is to hack their own bodies. The most common strategy, of course, is to hide. The kangaroo rat is a master of architecture.
It doesn't just dig a hole, it builds an entire complex underground tunnel system. During the day, it's 60 degrees outside, but inside the burrow, it's a cool 30 degrees. Even more impressively, it knows how to recycle moisture from its own breath.
The sandfish lizard is even more incredible. When in danger or when it's too hot, it doesn't run, it swims. That's right, it dives headfirst and swims through the fine sand like an underwater swimmer. The top layer of sand is a frying pan, but just a few centimeters below is a safe haven. But hiding isn't enough. You also have to hack your body. The fennec fox's enormous ears aren't just for looking cool. They are a biological heat radiator. Hot blood flows through a dense network of capillaries in its ears and is cooled by the air. A natural, energy-free air conditioning system.
The camel is another story. It allows its body temperature to fluctuate wildly from 34 to 41 degrees Celsius. This helps it minimize sweating, conserving every precious drop of water. It's like you accepting being a little hot so you don't have to turn on the air conditioner.
What about plants? They can't run away, so they must become master alchemists. The giant saguaro cactus can store tons of water in its trunk after a heavy rain. Its waxy skin acts like a waterproof coat, preventing water from evaporating.
Most special of all is the resurrection plant. In the dry season, it shrivels into a grayish-brown ball, looking as if it's been dead for 100 years. But with just a few drops of water, it will unfurl, becoming green and lush again in just a few hours. A spectacular resurrection orchestrated by Mother Nature. We humans are no slouch either. Thousands of years ago, the ancient Persians built incredible structures, ice houses in the middle of the desert. Wait, making ice in the middle of the desert without electricity? Exactly. They built huge cone-shaped structures with a special type of mortar. At night, they channeled water into trenches outside. The cold desert night would freeze the water. This layer of ice was then stored inside the structure, and thanks to its clever design, it could stay cold throughout the hot summer. Today, modern architects are looking back at these ancient designs to build energy-efficient buildings. They study everything from the clay houses of the Pueblo people to the termite mounds in Africa, all to find ways to cool down without relying on air conditioning. The desert is not just a harsh place on Earth. It is also a perfect laboratory, a blueprint for other worlds. That's why NASA frequently visits the Atacama Desert in Chile to test its rovers before sending them to Mars. If a machine can survive the night in Atacama, it has a chance of surviving on Mars. And if we find bacteria living in those conditions, the hope of finding extraterrestrial life becomes greater than ever. But ironically, it is we who are disrupting this delicate balance. Climate change is making desert nights warmer. Cities spring up in the sand, like Las Vegas or Dubai, radiating heat and light, dispelling the darkness and natural cold. We are inadvertently putting a blanket on the desert, breaking the perfect thermostat that nature has spent millions of years perfecting. Many plants need the cold to flower. Many animals need the dark to hunt. When we change the rules, an entire ecosystem is at risk of collapse.
The desert teaches us a crucial lesson. Adaptation is the key to survival. But it also poses a big question. Are we humans, with all our intelligence, adapting wisely, or are we just trying to bend nature to our will until it breaks? Next time you see a picture of the desert, don't just see the heat. See a world of extreme contrasts, of brilliant survival strategies, and a reminder that our Earth is more complex and magical than we can imagine. In your opinion, besides the desert,
Where else on Earth are there such crazy temperature contrasts? Share your knowledge in the comments section below.